Algebra 2 friends, we're back and we're going to be graphing absolute value functions today, as well as coming up with equations of absolute value functions based on their graph. So today is going to start pretty heavy on the graphing calculator, but don't panic if you don't have one of your own. Our school is offering you a way to get a free download on your Chromebook of a calculator emulator, which is the same one I use, so it works the same. And actually I'm going to show you how to graph these without a calculator today as well. And turns out it's a whole lot easier to graph without a calculator. So go figure. It's not often that case in Algebra 2, but this time it is. So first let's explore with our graphing calculator a little bit. We're going to be graphing the mother function or the mother graph of the absolute value of x. So in our calculator, you want to go to y equals, and if for some reason you're already noticing your screen doesn't look like mine, that means there's some weird modes, so you can just reset it and go back to factory settings that way. You can do that through the memory. We're going to use a lot of graphing calculator this year. So the absolute value bars are found in the math menu. So while I'm in Y1, I'm going to hit math, and then go over to where it says NUM, the numerical submenu, and then the very first one, ABS, absolute value. Now if you do have a calculator and it happens to be an older one, you see like ABS parentheses and then X. That means the same thing. Just the newer calculators have a text upgrade where it actually looks like what I'm typing. So the absolute value of x, we're going to be graphing this just so we all match with the same graph. What I want you to do next is go to Zoom. These are some pre-programmed standard windows. Depending on what you're graphing, you might want to choose a different one, but for Algebra 2, a really great Zoom window, a pre-programmed one, is called the standard window. It's called Zoom 6. So anytime I'm graphing and you're graphing and we don't look the same, try Zoom 6 and it'll probably bring you to the same screen, or else you have something typed in wrong. Or maybe I do. All right, so anyways, long story short, that is the absolute value graph, y equals absolute value of x. Most kids look at that and go, it looks like a V. You're right, it does look like a V. So let's think about why it looks like a V. And before we do that, I'm going to go to what's called the table. So second graph. This is an infinite scrolling table if you're in autofill mode, and it gives you a whole bunch of ordered pairs. And you know what, guys, I'm going to be honest, I probably could have come up with these ordered pairs on my own because I know how absolute value works. We worked with that last chapter. So for instance, one of those ordered pairs was 0, 0, because if you plug in a 0 right here, the absolute value of 0 is also 0. I'll use blue so you can see it. There we go. If you plug in a 1 for x, you get a 1 back. If you plug in a 2, you get a 2 back. Now if you plug in a -1 for x, and you take the absolute value of that, you get back a positive 1. Same thing with -2, you get a positive 2, and so on and so on. Now this is where we all get to have fun, because I can't graph. Ah, so close. Ugh. Alright, so that was supposed to look like what we saw on the calculator. It doesn't. But that is the absolute value of x. Now think about this for a minute. Why does it have that shape? Well, if you just had, real quick, I'm going to graph y equals x, which would be this line. What it did is it took this negative piece of the line and it reflected it up into the positive land, right? That's what absolute value does, is it creates a positive distance from 0. So that's why you get this V shape. Anything that was negative gets hoisted up to the positive region. So that's kind of neat, right? So we know what they're supposed to look like, and let's think about transformations as we graph these. So this next one, just to explore on our calculator, let's type absolute value of x minus 2 in the absolute value. So scooch on over. Make sure you hit a subtraction sign for that one, not a negative symbol. A negative symbol would give you something totally different. So there's the graph, and I don't know about you, but I'm seeing it being shifted. That vertex that's in the middle, I'm seeing it being shifted to the right too. So if you wanted more ordered pairs, you could go steal them from your table. And we just graphed 2, 0. So if I graph the ordered pairs that are around it, 1, 1, and 3, 1, that would work. I should graph some more ordered pairs. But clearly nothing's going to help me when it comes to graphing. You know, I do have some cool tools here on my program I'm using. Let's see if it helps. Maybe not. I don't know, let's see. I don't even know what happened just now. I'm going to undo that. And I'm just going to use a regular old pen. Okay. It was trying to make my graph better. But, you know, sometimes there's some people you just can't help, guys. And I think I might be one of them. All right. So the absolute value of x plus 3, again, in the absolute value bars. So I'm just going to overtype this to a plus and then a 3. I'm going to hop out of there. Makes me nervous when I have a weird empty space. All right, so that one seems to be shifted left 3. And if I stole some ordered pairs off my table, I would have saw those 2 ordered pairs around the vertex. And I know my graphs don't look really great, but if you look at the calculator, what you are seeing is what's called a lot of symmetry. So these branches we're going to learn have a lot of symmetry. What I'd like you to do is in your notes also make a point of noting down that this one was shifted. If I ask you for transformations, I'm asking for the shift. This one went right 2. This one went left 3. And then maybe I'd have you guess this in class. What do you think is going to happen here? Now notice the plus 2 is no longer in the absolute value bars. It's outside of the bars. So we're going to have to delete this, hop out of the bars, and then hit a plus 2. So if you guessed up 2, you're right. This was shifted up 2 units. So the vertex is now up here at 0, 2. And then one of the ordered pairs that I stole from the table would have been 1, 3, and also negative 1, 3. And then I ruin it by graphing. All right, so as far as the transformation, this one was shifted up 2. I bet you can guess what this one does. That's right, kids. I'm just assuming you said down 4. Let's double check on the calculator, though. Maybe you don't believe me. Also, good moment. You should be typing these with me. Because right here, a lot of kids type the wrong thing. They type a negative symbol. They're supposed to type a subtraction symbol. Those are 2 different things, so be careful. Totally shifted down 4. All right, so this guy was at down 4. And then his ordered pair off to the side would have been at 1, negative 3, and negative 1, negative 3. Again, could have stolen from my... That's ugly. I could have stolen from my table. Now, I should have gone back. They just wanted me to name the transformations. All right, cool, cool. So when I go to graph this next one, this time I do want to use a negative symbol. I don't want to have any other transformations, so let's delete that. Delete, delete. And then this is kind of irritating. You have to insert it, otherwise it's going to overtype. So I'm going to go second delete, which is how you insert, and then a negative symbol. If you just messed all that up, just delete the whole thing and start over. It's fine. It's not the end of the world. Of course, pause the video if you guys are struggling. All right, let's take a look. Ooh. So maybe you don't know what to call that. Lots of kids call that a flip. We need a little bigger kid term today in Algebra 2. This is called a reflection. And more specifically, this is a reflection over the x-axis. Some kids or teachers call this a vertical reflection. Totally fine. I get what you mean. The vertex, however, didn't change. It's still at the origin, but instead of going up and to the right and up and to the left, down to the right and down to the left. Talk about that in a minute. All right, so maybe you already think you know what's going to happen on 3 absolute value of x. Maybe you have no clue. That's why we're exploring with the calculator. Here we go. Oh. So at first glance, you might be looking at that going, what's different? What's different? And a lot of kids look at it and go, oh, it's skinnier. So the vertex hasn't changed, still at 0, 0. But notice, instead of 1, 1, like the original mother graph, this one has 1, 3 and negative 1, 3. So you are seeing a skinnier graph, but we have a better way of saying that. Ooh. Yikes. You know, how many years I've been doing this? You think I'd be drawing better. All right, so what do we call this? This is called a vertical stretch of 3. Seems simple enough. You know, there's a lot of things in math. They don't really come up with cute names for it. They just call it what it is. So they're like, hey, Bob, what do you want to call this? And he's like, I don't know, vertical stretch. Cool. All right, so the graphing calculator is awesome, but it is a little cumbersome for these problems because they're not really that bad. If you can identify where the vertex is and what's called the slope of the branch, you can graph them by hand incredibly quickly. And you don't have to like bust out the old calculator or fire up your Chromebook to get your emulator. It's overkill, right? We don't need to do that. All of these transformations that we talk about are going to be applied to all the other functions that we talk about later on in Algebra 2. So not using the calculator if you don't have to is really going to help you out in the long run. So let's talk about this. This is like the general form for an absolute value function. And it starts off with a number in front of the absolute value bar, which they're calling A. I overdid that, sorry. That's going to help you with the slope of the branch, okay? We'll get to that in a minute. And then it has absolute value of x minus h, and then plus k. So the h is referred to as a horizontal transformation in any function. So it's how it's shifted right and left. And if you notice, the examples we did earlier, x minus 2 went right 2, and x plus 3 went left 3. And for a lot of us, we think that seems backwards and weird. But here's why it seems backwards and weird. There is a built-in negative in that absolute value bar. So when you see x minus 2, that really is a positive 2 because that negative was part of the formula. So in this general form, if I ask you where the vertex is located, well, it's going to be located at whatever h comma k is. So if you can pull out those numbers, you know the vertex. The slope of the branch is a little weird because it's A, kind of. So what you're going to write down for me is that it's A, but it's up, but then it's to the right and it's to the left. It's confusing, Mrs. Abruzzo. All right, so it's going to make a lot more sense when we look at the problem. I promise. It'll make tons of sense. I swear. All right, so this next question, you're looking at it and already you're like, it doesn't look right. It doesn't look like what you just wrote down. So here's what I'm going to do. I'm going to rewrite it in colors and with all the pieces that we just saw in the general form. So y equals, the a value is 2, and then we have the absolute value of x minus, and this is the first thing that's weird. There doesn't seem to be anything inside with the x. So I'm just going to put 0. And then close the absolute value bar, plus, and then again, there doesn't seem to be anything, so I'm just going to put a 0. So now when I ask you, where is your vertex at? You're going to say, Abruzzo, my vertex is at 0, 0. It was not shifted right or left or up or down. The vertex has not moved. But the slope of the branch, that's a 2. Now, think about everything you remember from slope. Slope is rise over run, so it has to be written as a fraction. So 2 is 2 over 1. What that means is we're going to travel up 2, but then we're going to go not just right 1, but also left 1. Remember, absolute value bar has that weird V shape. So you have to, it's weird. I know we don't usually go right and left for slope, but it's not a line anymore. It's an absolute value graph. So my vertex is at 0, 0. And then for my slope of my branch from my vertex, I'm going to travel up 2 and right 1, and up 2 and left 1. And then I'm going to ruin it by graphing it. That's not the worst I've ever done. However, I kind of wish I didn't use red. Oh well. All right, to bring back an old topic, domain and range. So remember, your domain is from left to right, and it's all the x values. Okay? So think about this, domain and range. This guy's going forever. It goes forever to the left, forever to the right. So his domain stretches from negative infinity, use parentheses please, to positive infinity. And then your range, remember from a previous lesson, your range is all your y values from lowest to highest. Wow, that's ugly. Okay. So think about, all right, oh gosh, I think I'm making it worse. All right, try this. Range goes from lowest to highest. So the lowest the y value hits here is 0 with an ordered pair, so we're going to use a bracket. And then it goes up to infinity. So yeah, that old topic of domain and range, it's back. Yay. All right, so again, this one, maybe I'll rewrite it so it has the same colors as, you know, my general formula. There is a number in front of the absolute value bar. There's always something as a multiplier. If you don't see anything, that's because it's a 1. So it's like 1 times the absolute value of x minus, and then I'm going to bring out the blue, 3. Close the absolute value bar, and then there's nothing, so I'm going to say plus 0. So same function, I'm just using my colors so I can kind of match it up. The vertex is located at, now careful, it's positive 3 comma 0. You can either think of it as opposites when it's in the absolute value bar. I don't really like that though. What I would rather you think about is that there's a built-in negative, so this is really a positive 3 because the negative is part of the formula. And then the slope of the branch, remember slope has to be a fraction, 1 is really 1 over 1. So we're going to be traveling up 1, and then right and left 1. All right, here goes. Vertex at 3, 0. And then our slope is up 1, right 1, and up 1, left 1. You can keep going, but you know nothing's going to save my graph, so I'm just going to go for it. That actually wasn't too bad. Good job, Mrs. Abruzzo. All right, domain. Remember, domain is left to right. And this guy goes forever. So negative infinity to infinity. Somebody's out there, and you're already thinking ahead, and you're going, is the domain always going to be negative infinity to infinity? And the answer is, yeah, for this one, yes. All right, range. Range, careful on this. Yeesh. So ugly. Okay, so range is not negative infinity to infinity because there is a starting point to this range. It's careful, it's the y value. It starts as 0. That is a tricky one. A lot of kids tell me 3. All right, very nice. Ugh. So this time, I'm not going to bust out the colors if you don't mind. Well, I guess I could, but there's nothing in with the x, so there must be a 0 there. And then 4. So our ordered pair for our vertex is at 0, 4. So right here. And then your slope of your branch is this 1/2. So it's already a fraction. Oops, I'm supposed to use red. And remember, because it's a weird absolute value graph, you're going to travel up 1, but then you're going to go right 2, and you're going to go left 2. So we go up 1, right 2, and up 1, left 2. Oh. Ay, ay, ay. All right, so the domain, remember, all your x values, and those of you who've already figured it out, good job. Domain for absolute value functions is always negative infinity to positive infinity. The range, however, you gotta be careful. Range is the lowest y value. I just got my colors backwards. Darn it. All right, range. I give up. All right, range is 4 to infinity. Now, since I'm on a roll, let's talk about a couple other things. What if I asked you for transformations on this question? Well, there's 2 technically on this question. Everybody can see the up 4. That's obvious. The other transformation is that weird 1/2. Because the 1/2, instead of making it skinny and go up fast, is making it kind of wide and go up slower, it's not called a vertical stretch anymore. The official name is a vertical contraction. But if you called it a stretch, I'm okay with that. But vertical compression, I think, is what your book calls it. Vertical compression of 1/2. That's awesome. That's going to get you really ready for pre-calc, our next math class, if you can come up with that right wording. Oh, yeah. All right. Here goes. Now be careful here. Your vertex, remember how there's a built-in negative? So there's a 1 in front, and then we have an absolute value of x minus. Now, what is it subtracting where it actually simplifies to a plus 2 while it's really subtracting a negative 2? That's where that double negative thing comes into play. And then plus a 1 over here. So your vertex is located at negative 2 comma 1. And then the slope of your branch again is a 1 over 1. So plot that, negative 2, 1. And then our branch is moving, remember this means up 1, and then not just right 1, but also left 1. Up 1, right 1, and up 1, left 1. Why did I make that red? Oh well, go with it. Yikes. All right. Domain. Left to right, so the domain is stretching forever, like the other examples, negative infinity to positive infinity. And then our range is our y values from lowest to highest. So watch your y values here. This guy starts at a 1 and then goes to infinity. All right. So I know we're a little new to those domain and range ideas. You did do them a little bit in Algebra 1. So you're not super new, but it is very important. So if you keep wondering, how am I coming up with that? And you kind of take a stab at it and guess half the time, let's wrap your brain around it a little better. So either come in, get some help, or I don't know. I'm recording this in the summer of 2020, so I don't even know if I'm going to see you guys. Email me for some help. Yeah, how's that? All right, so let's talk about transformations, even though it didn't actually ask me to do this. This one was clearly transformed to the left 2, up 1. And that's it. So anytime that concept of identify the transformations comes up, you know what to do. All right, this next one, y equals, there's a 3 in front. That's going to help us with our slope. And then we've got x minus 4. And then normally it's plus k, but it's a negative 2, right? So that's okay. It works that way. It's fine. So your vertex is located at, watch your signs here, it's a positive 4 and a negative 2. The slope of your branch is this 3 over 1. Now, I kept saying, like, we're not going to use our calculator very much. If you were like, no, 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 I love the calculator, I want to use it, go ahead. All right, positive slope of 3, and then you're going to move up 1, right 1, sorry, up 3, right 1, and up 3, left 1. So vertex at 4, negative 2. From the vertex, you're traveling up 1, 2, 3, right 1, and 1, 2, 3, left 1. And hopefully you draw better. That wasn't too bad. Yay. All right. I just need a little confidence. Domain. Left to right. Like all these domains, they've been going from negative infinity to positive infinity. The range, however, starts here. It's very hard to write sideways on my tablet. Okay, I just want you to appreciate how difficult. For the lady who can't draw a straight line, this is pretty good, okay? So the range goes from negative 2 and then up to infinity. And I wonder if any of you have put some thoughts together yet. The range and the k value have some overlap there, huh? The k value and the range, the k value, and then I switched my colors up, the range. Similarly, what about the h? It has to do with your, not your domain, but your right and left shift. Well, yeah, because h means horizontal shift, right? So this guy, speaking of that, would be shifted to the right 4. Got that built-in negative, so it's a little opposite here. And then it was shifted down 2. So the more connections you can make on these concepts, the easier these become. And the more confident you feel when you test. All right, one more graphing. Oh, it's a good one too. All right, I'm going to try to... no, I'm not. I was going to do it without colors, but this is not really a good time to do that. All right, so y equals, this time there's a negative 2/3 in front. That's fun. Absolute value, we have an x. The formula goes x minus h. So for it to become an x plus 3, that must mean we had a negative 3 right there. And then plus k, which is a 7. All right, here goes. Your vertex is at negative 3, 7. Your slope of your branch this time is a negative 2/3. So the tricksy thing here, instead of going up 2 because it's negative, you're going to travel down 2, but you're still going to go right and left 3. All right, here we go. -3, 7. And then from that vertex, you're going to travel down 1, 2, and then right 1, 2, 3. Then down 2, and then left 1, 2, 3. And then you're going to hold your breath and try to graph. Wow. I could have done a little better. Oh, you know what? Sometimes you just need to go with it. All right, no shock here, guys. The domain is still -infinity to infinity. The range, now careful here, remember range is low to high. So, if I asked you how low does this function travel, the answer is really stinking low. It goes down forever. So the range actually starts at -infinity, but then it stops up here, whoops, up here, at 7. And once again, that k value is going to have something to do with some part of your range. In this case, because we have that reflection, oops, spoiler alert, because we have that reflection, it's the top of your range instead of the beginning of your range. Speaking of transformations, let's talk about them. So everybody can see the left 3. Everybody saw the up 7. But there's actually 2 more transformations here. We have a reflection. And then I would love for you to say reflection over the x-axis, because yes, there is a different type of reflection out there as well. And then the fact that it's a 2/3 instead of just a 1 in front, that's a vertical compression of 2/3. If you said stretch, it's fine, but I would like you to say the number 2/3 with it. So a vertical compression of 2/3. Get out of the way, face. So anytime you have a number in front that is smaller than 1, so like 2/3 is smaller than 1, it's going to compress it. It's going to make it go up slower. If you have a number bigger than 1, it's going to stretch it. It's going to be a vertical stretch. Go up faster than a factor of 1. So now we're going to take everything we know and we're going to flip it. And we're going to give you the picture, and you are going to give me the equation or the function. So you can either say y equals or f of x equals. I'll just keep it the same that we have been doing here. Remember, the formula is y equals a times the absolute value of x minus h plus k. So your vertex is located at h comma k, and then the a value is the stretch, or the slope of the branch, I should say. So this guy right here, this is called the vertex. So you have your h and you have your k. Boom, right there. So I'm just going to kindly slide those numbers in here. This is a 2 and this is a -2. So the only other thing you need to figure out for me, now I'm not going to say plus -2, that's goofy. So I'm just going to call this -2. The only other thing you have to find out for me now is this a value. Now, first of all, the fact that the absolute value graph is opening upwards, that tells me a is positive. So what I'm going to do is, I know this is weird, I'm just going to write down a plus sign. And that's just so I don't screw it up. Because what I have to do now is count one of the branches. And this is where kids get into trouble, because they're like, well, which one do I go to? And the answer is, it doesn't matter. You already know the slope is positive because it's opening upwards. So if you go up and to the right and up and to the left, like your neighbor might say it's -2/1, and I might say it's 2/1. And who's right? Well, the positive 2/1 is right because it's opening upwards. Remember how that slope of the branch goes in both directions? So you would just have to use your common sense as far as whether it's positive or negative. So the point, though, is it's traveling from the vertex to one of the branches. It goes up 2/1, so a +2 slope. That looks a little weird, I know, to put a +2 there. If it bothers you, then get rid of it. That's a whole lot of 2's in a problem. I'd be real nervous if this came up on a test and I just had a bunch of 2's, but we're right. All right, one more. Right away, I notice it's reflected, so maybe in my brain I'm going like, oh, it's going to have a negative in front. You're right, you're right. So x minus absolute value of x minus h plus k. And right away, I should be able to pinpoint my vertex. That's your h and k. So there's h, and here's k. And you just place those numbers right where they belong. And this time it is a positive 1, so I can go ahead and put the plus sign down. Remember, there's that built-in negative right there. And we already talked about this. It's got a reflection, so I know it's going to be a negative value right here. If only I could figure out the slope, huh? So from the vertex to one of the ordered pairs, you can go left, you can go right. I don't care. It does not matter. This guy is traveling down 2 and then right 1, 2, 3. So that means you have, we already knew it was negative, 2 over 3. Boom, there you go. That's a fun problem. That's synthesis in math, guys. You can take a concept and you can move one direction with it. You can graph it, and then you can reverse and come the other direction, and you can write the equation from the graph. Definitely need to practice this. Again, you don't need a calculator to get these right, but it's nice to have one handy in case you're wondering if you screwed up. It will slow you down to use the calculator, but it doesn't hurt. And if I was on a test, yeah, I'd be checking. Please practice these. And if you have any questions, let me know. All right, good luck, everybody.